All right, folks, you have reached the last podcast of Unit 7. It's on salt hydrolysis. So we're going to explain what salt hydrolysis is. Shouldn't take long, but you're definitely going to need notes on this one. All right, let's remember for just a minute about strong and weak acids and bases. For example, we have hydrochloric acid. Hydrochloric acid is considered a very strong acid, and it breaks up into hydrogen ions and chlorine atoms when put in water. Now remember, this completely dissociates, and that's why you have an arrow like this. It's only going in one direction. So the hydrogen ions and the chlorine ions are floating around in the water. Right? And since you have hydrogen ions, excess hydrogen ions in the water, that's an acid. All right? And it's a strong acid because it completely dissociates. Now what about a weak acid? Well, down here we've got acetic acid, and now notice you've got arrows going in both directions. All right? The reason you have arrows going in both directions, if you remember from weak acids, is yes, acetic acid dissociates, but the majority of it stays as HC2H3O2. It does not actually dissociate into a hydrogen ion and an acetate ion, so it is a much weaker acid. It is very happy staying, even in water, when you put it in there, it's very happy staying as a complete compound, all right, just in the water. Okay, so that's important to understand because strong acids and weak bases, strong acids behave differently from weak ones. Right, so let's look at a neutralization reaction. We did this in a previous podcast where we took hydrochloric acid and sodium hydroxide, and what they do is they dissociate when they hit water. So the hydrogen and the chlorine break apart, and the sodium and the hydroxide break apart. So you get a hydrogen ion and a chlorine ion, and a sodium ion and a hydroxide ion, and that's what you see down here in this equation. Now what happens is the hydrogen and the hydroxide get together and grab a hold of each other, and they make water, H2O. And the sodium ion and the chlorine ion remain dissolved in that water. Now, that's pH of 7. Why is this a pH of 7? Because the sodium and the chlorine do not add a pH in any way. Right? What we're looking for are the hydrogens and the hydroxides, and you'll notice they have gone together to make water because we have a strong acid and the sodium and chlorine have completely dissociated. But what happens when we have a weak acid? Well, again, let's deal with acetic acid because we're familiar with that, and sodium hydroxide because we're familiar with that. And let's assume for purposes of argument that they break up, okay, like this, into something that's positive and negative and positive and negative. Well, we would expect the hydrogen and the OH to hook up again and make water, and then have the sodium and the acetate all sitting off by themselves. That does happen to some extent. But remember that the acetate ion is very happy with the hydrogen and will stay together as a compound because remember, it is a weak acid, it does not completely dissociate. So if we put in equal amounts of acetic acid and sodium hydroxide, what's going to happen? Well, all of the sodium hydroxide is going to dissociate because it's a strong base. But not all, in fact very little of the acetic acid is going to dissociate. So what you're really going to end up with down here is some, you're going to end up with some HC2H3O2 in the liquid. You're going to end up with some HOH or water. You're going to end up with some Na+, and you're going to end up with some, a little bit of C2H3O2. But virtually almost all of this stuff is going to end up back here. All right? So for that reason, when the water dissociated, the hydrogens are being picked up by the acetates. So the hydrogens and the acetates are getting together to form an acid. So what's left in solution? Well, the stuff that's still left in solution is the sodium and the hydroxide, which means that in this case, we're going to have a base. All right, so your pH is going to be greater than 7. That's a greater than sign. Greater than 7. pH is going to be bigger than 7 because you're going to have OH ions sitting in there that are not offset by the hydrogens because the hydrogens are spending all of their time back with the acetate ions. Okay, so that's kind of what's going on. So Strong acids and weak bases, they're going to have the same concept, except instead of making a base, they're going to make an acid. Okay, so let's look at salt hydrolysis. What exactly is happening in salt hydrolysis? Well, if we have water and we add NaCl to it, what happens is we get Na plus and we get Cl minus, and they're completely separated. Okay, and nothing happens. We get a pH of 7 because they're just all sitting there. Okay, now remember that water dissociates. So of course you have HOH, or you can call it H2O if you want, it doesn't matter. All right, but remember, water dissociates, so you get some H plus ions, and you get some OH minus ions as well. Remember, these are 1 times 10 to the 7th, and this is 1 times 10 to the 7th for concentration. Right? All of that we did in our pH unit. So these are balanced. So that's why your pH has a pH of 7. But what happens when you add sodium acetate to water? Well, sodium acetate breaks up into Na plus and C2H3O2 minus. Now remember, we do have water here, all right, but we also have H plus ions and we also have OH minus ions, and they're floating around in the water. Now remember that the acetate ion likes to be a weak acid, so it will go and bond with the H plus. Right, now sodium, remember sodium came out of sodium hydroxide typically, so sodium is a strong base. Don't worry about it, sodium hydroxide is a strong base, so it completely dissociates, but the hydrogen and the acetate get together and they form acetic acid. All right, but they form it as a compound in the water. So what's left over in the water? Well, what's left over in the water is OHs. So if we add sodium acetate to water, this actually is not going to have a pH of 7. It's going to have a pH that is basic. And that is what salt hydrolysis is all about. So, salt hydrolysis is a process in which the cations or anions of a dissociated salt, meaning it separates, accept hydrogen ions from water or donate hydrogen ions to water. So, this dissociates into sodium and acetate, all right, and it has a negative charge, and then what it does is it accepts hydrogen ions, right, and it bonds with them, leaving OH ions in the water that are free, and as a result, you have a basic solution. What happens if I add NH4Cl to water? Well, NH4 is ammonium, right? It's not ammonia, it's ammonium, and that puts NH4 in the water, and it puts Cl minus in the water. Now let's think about one of our favorite acids that's a strong acid, it's HCl. So we look at the Cl and say, well, that is the anion of a strong acid. What about NH4? Well, we've talked earlier in previous podcasts about how NH4 acts as a base, right? Because what it does is it breaks apart. We get NH3, and we get the H plus ion that goes off. Now, where does it go? Well, it goes and it gets with the water. So we end up with H3O with a positive charge, the hydronium ion, right? So as a result, there are free hydronium ions running around in the water along with NH3, right? Well, in H3O, or just having that H sitting out there, either one, you can look at it either way, that causes an acid. So if you throw ammonium chloride, which is a salt, right? Remember that a salt is simply an ionic compound. If we throw ammonium chloride into water and it dissolves, what's going to happen is it is going to make the water slightly acidic. Right? So your pH is no longer going to be 7. So you aren't going to get that NaCl type even pH. So here's a general rule. The general rule is that salts that produce acidic solutions contain positive ions that release protons to water, and salts that produce basic solutions contain negative ions that attract protons from water. In English, let's look at what happens. We take, I like using these just because you're familiar with them. We're just going to break them up here, right? And we have sodium, which is positive, and that's part of, you could think of it as NaOH. And we have C2H3O2, and we can think of that as acetic acid because it's negative and it's going to pick up a hydrogen. Okay, so this negative ion, this is this bottom one, right? This negative ion is attracting a proton, H+. It's attracting the proton from the water and making acetic acid, which leaves OH negatives in the water behind it. Okay, and so this produces a basic solution. Whereas ammonium chloride produces NH4, which has a positive charge, which then breaks apart into NH3, which is ammonia, plus an H plus ion. That H plus ion is free to go and be with the water, so it produces H3O, which is hydronium, which is positive, okay, and which is an acid. So it's going to be this one because salts, this is producing an acidic solution, okay, because it's releasing protons into the water. Okay? All right, that's it. Please do the worksheet on this one. I know it's confusing. Maybe you have to watch the podcast again. Maybe you have to ask us some questions in class. Whatever works, we'll be more than happy to help. Okay? That's it. Congratulations. You have finished acids and bases. We'll see you in class.